Okay, I'm gonna do a quick video about quadratic and exponential regression, mainly because I don't think everybody out there has their calculator, and so all the instructions given are using a particular calculator. Imagine you don't all have one, so I'm going to show you a version on the web that you can use for all types of regression. So this includes linear, quadratic, exponential. And what's cool is you can use it to decide which one you think is the best as well. So regression is basically a way of taking a set of data points and deciding, is there an equation that can be used to explain those points? So we're trying to decide, like, is it, what kind of relationship is there? Is it linear, quadratic, exponential? And then deciding which one is the best way to represent the data. And so they go through a whole explanation. But basically, you're going to go down here to the questions and you're going to see there's a table, x values and y values. And so, if we were to graph those, this would just be a bunch of dots. But what you might see is you might see that there's some kind of trend. So I'm just going to give you an example. If my graph looked like this or whatever, I might think, oh, it looks like there's a trend and it's like a quadratic graph. It goes like this. And so this is what we're going to be doing. We're going to be saying, what is that graph? What would be the equation of this graph? And there's a way to do that. And so we're going to go here to a website that I found, and you're going to follow the link in the video description to this Planet Calc. And there's a function approximation with regression analysis. That's a long way of saying different kinds of regression. So we're going to be looking at, and they can do a lot of different types of regression. But once you go here, you're going to see a couple of boxes. You're going to see a box for x values. You're going to see a box for y values, and then a bunch of switches. And the only ones you need right now for this one is quadratic and AB exponential. Linear, you could use on some of the previous lessons. So I just want to make sure you're aware of that. Linear regression can be done using this one as well. So I'm going to go in, I'm going to delete what I have already typed. And we're going to type in all of our x values. And it says separated by a space. So we're just going to put space. Here is, sorry, my computer's a little laggy right now. Okay. All right. We're going to do, 1 through 9. That's easy. So we're going to do 1 space 2 space 3 and all the way 8, 9, all the way to 9. That's it. And then that's those. And we're going to go back and we're going to do these. This might take a little longer. 16.8. You got to go in order. Again, my calculator is a little bit laggy. Sorry about that. I think the video jumped, but basically I'm typing the y values in now. 8.6, 8.6, 4.3, space after each one, 1.1, 0.4, 0.9, 4.1, 9.2, and 15.6. Now, this, if you look down here, it's already calculating for me. But basically, I'm going to click calculate. It's going to calculate the quadratic regression. So again, I've typed in x values, y values. I'm going to scroll down again. And now we've already got this information, but I want to look down at here the graph first. So you see these dots are these little crosses. These are the things we put in. See, there's the different values right there, right? 6 and 0.9. 2 and 8.6. Anyways, these blue crosses are the points we put in, and the two graphs are the two options. We have quadratic and we have exponential. Now, clearly, exponential does not fit very well, the green, because it's just a straight line. I don't even know why that did that, but the orange line, the quadratic line, is really good. Like it's almost crossing through every point. It's very, very close to being exact. So that means that's going to be the one I pick. So what that means, first of all, is I go back and I say model type quadratic. Okay, so when you select quadratic on this, you're going to need to put an A, B, and a C value, and they're going to give us those. That's going to be part of this equation right here. If you choose exponential, you're not going to have anything for C. You're only going to have an A and B. And so just so you know, you're going to put none when you do exponential. But we have quadratic. So we go back and we see A, B, C. So I just want to make sure it's clear. This is A, this is B, and this is C. So A, 9985. Now we'll do 1 because almost 1. It's rounded up, which is fine. So just be aware there's going to be some rounding. B is negative 10 point something. Let's see what we got here. There's negative 10.04. And then C, 25.38. There's 25.38. So that's it. So all I'm doing is I'm entering my values, looking at the graph, deciding which of the functions works best, and then looking at the A, B, and C and entering them here. Now, if they're close and you aren't sure which one is the better fit, this number right here is the best thing to know, or these. So obviously, these, the correlation coefficient. It didn't even give us a correlation coefficient here because it's so bad. So this is the only one that even makes any sense for the answer. And so you just have to use common sense. Which one looks like the better match, quadratic or exponential? And then choose your answer based on that. I hope that's going to be enough for you guys. But basically, every single one of these is the same idea. Enter the values for X and Y, and then look at the model type, and so on and so forth. And then that's the first 6 questions. And then starting in question 7, they go ahead and give you the answers that you would get. And these would be the answers you get from this, like these numbers here, correlation coefficient. That's the R and the R squared. So let me say one thing about R and R squared. So R and R squared are basically a way of saying how good is this? Is it a really good model? Does it fit? And so this is good. Almost 1. Rounded up, it's 1. This is almost a perfect match. So that's the first thing you need to know. So when I look at this and ask me about the relationship, okay, first of all, R value is high, 998. Okay, so that means it is a good relationship, a strong relationship. And it's positive because it's growing. And you can see that the algae is growing. I'll let you read all of this on your own. I'm not going to go through every little part of it, but I want to just make sure you understand that this number, R, tells me that this is a good relationship. It's a strong relationship. If it was like 0.4, that's not strong. That means there's not really that good of a relationship. Lastly, choose the model to predict the amount in 87 days. So what you have to do is you take A and B and plug it in to A and B in the equation, A times X to the B power, and then you plug in 87 for X, and then you find the answer. That one should be pretty easy for you. You're just plugging in A, B, and then you're plugging in X for 87. Okay. And you can probably guess the answer based on this. You can see that, 70 is 388. So it's got to be one of these two, I'm thinking. But you'll have to do it yourself and calculate it and see what you get as your answer. So that's it for lesson 9, and hopefully